Hello, everyone, and I would like to officially welcome you to today's webinar on advanced terrestrial and non-terrestrial communication networks for the next generation of drones. My name is Maja, and I will be your host for today. We are glad that you could all join us today, and thank you very much. We have an exciting program ahead, and before we dive into today's topic, I would like to briefly introduce you to MDPI, the publisher behind of this event. MDPI is a pioneer in a scholarly open access publishing, and we have supported academic communities worldwide since 1996. MDPI is based in Switzerland, in Basel, and has the mission to foster open scientific exchange in all forms across all disciplines. Currently, we have 469 diverse and open access journals, and our publishing activities are supported by 295,000 academic experts who share our mission of delivering high-quality service to our authors. Today's webinar is organized under one of our journal, Drones, which is an international peer-reviewed open access journal published monthly online. And the journal focuses on design and application of drones, including UAV, UAS, RPAS, and likewise contributions based on unmanned marine, water, underwater drones, unmanned ground vehicles, fully autonomous driving, and space drones are also welcome. This is the process of 20 minutes each, followed by a Q&A time moderated by the chair. If you have any questions for our speakers, please post them in the Q&A box at the bottom of the screen. And please remember to mention the name of the person to whom are you addressing your question. I would also like to remind everyone that this webinar is being recorded, and the recording will be made available online as soon as possible. Finally, I am delighted to introduce our webinar chair for today, Professor Dr. Alessandro Vizzarri from University Rome Tor Vergata. Thank you very much for chairing today's webinar. And that is it from me. I now hand over the microphone to our chair, and I hope you all enjoy today's webinar.
Thank you very much. Thank you very much. Good morning, everybody. Thank you very much for the invitation. It is an important opportunity. The webinar my name is Alessandro Vizzarri. I am researcher and professor in telecommunications at University of Roma Tor Vergata. And the main scope of this webinar is to analyze the most important trends regarding the drone in terms of communication networks, applications, platforms, and innovative services in this field. We have important speakers today. I would like to thank all of you. I think we can start. With the first speaker because we have a lot of speech. So I would like to introduce Professor Kishore, that is currently working as a remote pilot instructor, the director and head of the department of Danwantari Drone Pilot Academy at Danwantari Group of Institutions, Bengaluru, India, and he also working as a lead contributor for Bureau of India Standards in Section Committee. He also the moderator of Katie Vala Forum Architect Dialogues across the globe. He's a senior member of Tripoli. He has published articles in cdc.org, gave keynote speech at Session Initiation Protocol International Summit in Paris, and played key roles as panel moderator, panel speaker in several international ComSoc IEEE conferences. He is the recipient of IEEE Bangalore Section Outstanding Industry Award, IEEE Bangalore Section Award from ComSoc, from Educational Services, and so on. And Professor Kishore, I would like to leave the floor to you, and please, you can start your presentation.
Thank you, learned scholars, and especially chairperson and the coordinator who introduced us. I thank the organizers to have given me the opportunity to speak first due to my own request. I will just immediately share my screen and continue my talk. Thank you. Okay, thank you. The topic is advanced terrestrial and non-terrestrial communication networks for next generation of UAVs. We also call it drones. I came across in my lecture series a definition of a drone. Someone want to make note. It is good to start with definition. Dynamic remotely operated navigational equipment. It is an acronym drone, and UAV is the most scientific terminology, unmanned or uncrewed aerial or aviation vehicle. And if you combine the associated ground control station, it will become UAS. UAV plus GCS becomes UAS, just to set some terminologies right. And I'd like to further. This is me. Thanks for introducing. I would like to thank Dr. Parameshachari also to have connected me to MDPI. Just want to clarify some interesting things. When you look at unmanned flights and manned flights from a satellite launching perspective, they look alike. For a generic audience, I want to compare these two things. In case of UAV, the scenario currently, most of the UAVs are not aimed at manned flights. There are two aspects of manning. The pilot is inside the loop, inside the cockpit. That is how all the aircrafts are there. Another scenario is there is no pilot, but passenger can be there, can be air taxi or ambulance. In this case, as you see, a lot of effort is required to launch a rocket for unmanned flights before they do manned flights. The blessing in disguise for UAV industry, it's a lot less expensive as compared to launching a rocket. UAVs are several types. Primarily, there are three categories: rotary crafts, another is fixed wing type, and the hybrid variant of these two variants. And most popular is electrically operated vertical takeoff and landing variants are very popular. So far worldwide, in a very day-to-day basis, UAVs are not carrying people here and there. We are mostly looking at UAVs carrying logistics supply chain, as we see in Amazon Prime in US, and US Postal Department using them, and some other trials here and there. So this just to keep the context for those who are looking at UAV industry for the first time. Also would like to say that there is a way to look at various altitudes to differentiate where these flying objects can be positioned. For example, we have on the ground, we have 5G wireless devices you all carry, or 4G LTE devices. And of course, they also have Internet of Things services with sensors. And above them, around 120 meters, it is printed as 200 meters. Some of the nations follow the FAA guideline of 400 feet as the safe limit of the UAV without seeking government permission to fly when they are in a green field, green zone, safely away from any airfield. The reason for restricting the UAV height without government's permissions to 400 feet is that FAA felt, very rightly they felt, that if any aircraft is trying to land any 360 degrees in the runway, normally there will be a particular direction in which it will land. In emergency conditions, it may be trying to come in different angles. And in any case, the airfield, when you draw a triangle with the height of the triangle 400 feet, the angle of descent when it is trying to land with instrument landing, with properly instrument landing, it will align to the runway. In some case of emergency situations, pilot might make their own decisions. So in any case, you should not have a problem situation where as a academic work or a experimental work of a UAV should not harm a manned aerial flight. That is the reason why UAVs are supposed to be below 200 meters, generally speaking. But if I want to fly a UAV above 200 meters, as this visual says, I need to submit my flight plan to the concerned aviation authorities. In case of India, it is Directorate General Civil Aviation or Ministry of Civil Aviation in their portal Digital Sky. Every nation will follow the similar procedures, be it in UAE or Canada, UK or America. Now we have number of satellites because the topic of the day is talking about terrestrial and non-terrestrial. When we say terrestrial, all the mobile phones that you use, they are terrestrial networks, and non-terrestrial, typically you can just start off with a definition that satellites are non-terrestrial, simple definition. So in satellites, three major categories. One is low Earth orbit, which is around 180 kilometers, medium Earth orbit, 2000 kilometers, geostationary Earth orbit, and that is 36,000 plus kilometers. These are broad classifications. And we now talk about within them, we have UAVs that have evolved from being experimental to really being used in civil, commercial applications, and also military. So we talk about a lot of three acronyms. Up front, I want to give those names so that it is easy for you to look at other slides. One is high altitude platform system, not in this slide. Another is medium altitude platform system, not in the slide. Low altitude platform system. So just remember three acronyms. HAPS, that is high altitude platform system. MAPS, medium altitude platform system. LAPS, low altitude platform system. Just remember these acronyms. And so when you look at typical deployment scenario of the networks, taking into account of satellite networks and then the terrestrial networks, which you are already familiar. In between, we have something known as an aerial network, where you have acronyms like ground to air, air to ground, similarly air to space, space to air, kind of interactions between them. This is how we can say that there's a three-layer architecture of these flying machines. And we realize that to take this to scaling it up to a large level, normally all the UAVs currently are done in a visual line of sight, very low scale of operations. And there you don't need the UAV traffic management or networking with the satellite support or with other communication infrastructure. But when you want to scale it up to various applications, which we are going to see, we'll talk about various potential applications of UAVs and where we need these communications of terrestrial, non-terrestrial communications, especially the 6G that we talk about from 3GPP. So 6G world in 2030. By the way, this is the year then India wishes to see itself as one of the dominant players of UAVs, like the UAV hub of the world. So you see the industry of 6G is positioned to tackle the climate change or the earth and society environmental challenges, apart from taking care of the regular requirements of taking care of voice, video, data for consumers, including the aerial consumers. You see here HAPS. I mentioned high altitude platform systems, and above them the satellites. So as you may be knowing that the 5G technology and all, they are useful for satellite communication as well. So this is how when 5G and 6G, the 3GPP kind of wireless is deployed in all the communication systems in the world, the latencies will improve and the performance overall of all the systems connected and associated with them will be better. So that is what is expected in times to come. So you can see this broad classification of keeping the UAV in the center, satellite networks above it and below terrestrial networks. And here you have different UAVs named as Drone 1, Drone 2, Airship 1, Airship 2. Historically, these airships have come when aviation industry is growing, and they have been taken a back seat for some technical reasons. So we are trying to do further research to make them more safer, at least for initially, to keep them as some kind of a aerial base station or a low altitude platform system as a substitute for the base stations on the terrestrial, which we are going to see such scenarios coming forward. So here is this is thanks to Nokia's graphic. High altitude platform system, the visual that is indicating the UAV looks like a Zephyr of Airbus, like it's all on the surface with a solar panel, and it has a big wingspan. And here it is used to work as a substitute for terrestrial base station, as you see on the left. So terrestrial base station exists on the left, and on the right there is no base station due to any reason. The HAPS can fill the gap of where the base station is not there. But in order for it to work in that way, it needs to take support of the NTN non-terrestrial network gateway, just like a satellite mother earth station, and they're connected by the internet on fiber optics. This is the scenario of high altitude platform system, typically in the range of 17 kilometers and above the earth. 17 to 22 kilometers. And as I mentioned, the acronyms like high altitude platform system, low altitude platform system. This is how we can demarcate. In between this 12 kilometer to 17 kilometer, there exists a hidden missing element that is called medium altitude platform system, MAPS. In fact, for those of you who are following defense information, India procured 31 units of MQ-9B from General Atomic of America. They have sold these 31 units, which are MAPS, which is meant for Army, Air Force, Navy, military applications. So we now in this talk, we talk mostly about civil and commercial applications. And so now this is about the HAPS and the LAPS. And now the network that is mentioned here, this network is powered by not just the terrestrial ground network, but satellite network, and that's how it is generic mentioned as a network. So I would like to bring to what is happening today in terms of 3GPP standards. 3GPP is third generation partnership project that is release 17. Compliant technology is already in place, at least from the maker point of view. The buyer, that is the telcos, have to deploy them. And then there is a gap between 17th release to current state of the practice. For example, currently the world is at release 19 and 20 marginally, the where that research is going on. In future, it will be release 20 and release 21. The milestones of these releases from this year onwards will be to see that non-terrestrial networks will have a radio access and a protocol for combined terrestrial and non-terrestrial kind of a 6G new radio will be created. And there will be an interworking features of this terrestrial, non-terrestrial. And that is what is of matter of interest for our talk, because all the speakers are going to present on this context. So in the release 21, that is few years, that is 2-3 years from now, you will see that enablers for non-terrestrial network support, including the radio access or protocol for both TN and NTN, networking enhancements will happen, versatility will happen. This is thanks to Mavenir, one of the telcos, OEMs based out of India. And from 5G to low latitude latency applications. So basically 5G is there in place better than 4G for its virtue of being of low latency and also giving higher throughput. And in case of that, we see that in the context of 6G, the new evolution of NTN IoT and NTN new radio is going to leverage existing 5G and existing narrowband IoT, existing low Earth orbit, medium Earth orbit, and geostationary orbit satellites, and then take that mobility to NTN to NTN, NTN to TN, means mobility that is happening in the non-terrestrial world and also mobility between non-terrestrial to terrestrial. These scenarios are supported such that even when you are using this non-terrestrial, latencies are similar to what you experience on the ground. That is the benefit of using these advanced concepts. Then traditionally satellite communication used to have a latencies of the order of 500 to 600 milliseconds. That has been improvised thanks to 5G deployments and work towards IoT NTN and NR NTN. That's the, and you don't need to use any satellite phones for your work. You can just use commercially available off-the-shelf phones, third-party applications, etc. These are some things that to say what for we use UAVs. These are some of the 8 applications one can talk about. Traffic management, city traffic management, disaster relief, autonomous driving, crime prevention, remote treatment, and agriculture and ground vehicle positioning. These are some applications that, in fact, UAV traffic management requires that we need to have the ongoing research and standardization efforts on UTM across the globe by NASA and EASA and ICAV and ISO and Indian Bureau of Indian Standards. UAV traffic management is getting stabilized. Once it is ready, then beyond visual line of sight will be operational, where we can open up the UAV for supply chain logistics and other applications. To summarize, we can just classify 4 major applications of the urban air mobility, potentially including possibility to keep human being in the passenger seat, giving facilities similar to the safety that you get in the regular aviation. So we have this package delivery, that means like supply chain logistics, and multimodal transport, that means giving people the bus services, the metro, train, and other also aviation, that aerial services, search and rescue operation, disaster relief, weather forecasting. As I mentioned, some acronyms: high altitude platform system, low altitude platform system. They are very much useful in weather forecasting as research done by NASA and others. Wildlife monitoring and agriculture monitoring, precision farming, and personal ride share and medical commute. Any medical application you are to, in India, there is a provision called Garud, government authorization for usage of drones for medicines, delivery of medicines. Tata 1mg is already delivering it in Uttar Pradesh state, Dehradun, other areas, hilly areas, to deliver medicine. Similar to Rwanda, one African country, where using fixed wing aircraft, they're delivering the medicines, etc., for one hospital to many personal healthcare centers. Similarly, surveillance and for intelligence purposes and military operations, this can be used. And this is the source from MDPI's document. Now I have worked on the 500 global smart cities, for which I was awarded doctorate. And India has 100 smart cities. And why we talk about them is that initial consumers of this UAV, terrestrial, non-terrestrial, will be the modern urban cosmopolitan locations, the big cities. So amongst Indian cities, the 100 cities may be the initial candidate selection that we can make to deploy some test protocols to see how all this UAV terrestrial, non-terrestrial is working. And government is willing to support, because there is an apex body that recommended to Government of India to use 5G and 6G for communications to be used inside UAV. Currently, for those of you who are listening first time about UAV industry, currently UAV, when somebody does not mention explicitly, the communications that we use are on the Wi-Fi frequency using pulse width modulation and the pulse position modulation, and they are only limited by few channels. And if there is a multi-channel concentration and multi-users, there's going to be noise and then also crosstalks, and it's not viable for scaling it up. So the global think tank has already suggested to use 5G and 6G, etc. for the UAV communications. As we see, the design of 3GPP, including the digital unit and the agents and the structure of the entire the RAN and core is designed in such a way that it is suitable to the UAV applications. And so you have on the edge the LEO satellites. In the core, you have got MEO and that HEO satellites. And at the bottom end, you have this UAV swarm that is made up of digital units. You also have some context of the vehicle area network and also flying area network. These are the evolutions that have happened to come to the stage where we are talking about terrestrial, non-terrestrial network to cater for the ad hoc way that networks connect with each other in maybe on the mobile area network or on the vehicle area networks, and also flying areas, the way the connectivity can happen and interaction can happen. So you have these software-driven networks and clouds supporting in the evolution of these standards. One is network function virtualization, and you have got NTN gateways and the satellites. And so we have got a user layer and an edge layer to support in the communication paradigm. So you have the world consisting of UAV in midst of all these electrical deployments, and you've got roads and vehicles and various industrial setup. You've got drone as one of the integral part of the world, which is the remote controlled drone with an NR, new radio light version that is shown here. I would like to further take you through what is going to happen in near future, 5 years from now, is that there will be a number of eVTOLs moving around in the cities and maybe carrying people or the passengers from airport to different locations, or the patients from who like ambulance. That is going to happen very soon, and that requires a lot of vertiports to be constructed to make this happen. So this is where the UAVs are going to land in a vertiport. This is a typical vertiport. Looks similar to helipads, but it requires more infrastructure, such as computational fluid dynamics, maintenance and repair activities for the UAVs, programming for the UAVs next schedule, material movement, connectivity to multimodal mobility of the other city environments as some of the features of the vertiports. This is a very interesting application where there is a reinforcement of learning between the road traffic and UAV traffic, where potentially both can help each other. So if you want to improve the road conditions, use the data coming from observation by the UAVs, where they are capable of observing, looking down using lidars and cameras, and accurately tell you the distances that cars, in case of Tesla 5, the cars need to maintain for their autonomous operation. And the data also helps in UAVs to avoid collisions. So it's a research that is published, and it's a very interesting observation that this is how the data sets can be created for further researchers to help in improving the road accidents. I am just after this talk going to one family where there was a road accident yesterday. One great leader of a company on a road accident, we lost one great technical person. And so road accident, we look forward to a day when there is no road accident on the planet Earth. Probably by more research on these kind of talks that MDPI is doing, we will arrive at that particular scenario. So now I have conceived a few of the challenges with my knowledge of 30 years in telecom domain and around 10 plus years in civil UAV industry and 6 years in military. These are my thoughts on what are the challenges and what we need to do for taking the terrestrial, non-terrestrial innovations further. One is that autonomy at a global scale for on-demand ad hoc UAV context has to happen. That cannot happen by silos like only US or some Europe or some pockets of China. It cannot happen. It's for the whole globe. We need to evolve it, and cooperative, collaborative infrastructure such as mobile operators are already sharing the towers to minimize expenses and wastage, reduce wastage. They need to do mobile operator sharing of satellites wherein the transponders, uplink, downlink frequencies out of spectrum, and to help low latency applications demand no delays and sometimes subjected to service level agreements for guaranteed availability, throughput, and QoS. To achieve those things, we need more and more collaborative innovations. Next point is that beyond visual range, remote identification and tracking, that is for attributability. If one UAV is known to have violated some safety norms, can you attribute that ownership of the UAV to one individual or a firm or the number of the UAV even from a remote distance? That is one challenge which the global industry is trying to solve in different ways. Japan has its own approach, Europe and America have their own approach, and every nation is trying to do remote identification and tracking. One of the known methods of remote identification and tracking is follow how wireless industry identifies a mobile device. So similar features of a SIM card can be attributed to a UAV device so that you will be able to track it and trace it. And UAV traffic management enablement across global vertiports. Just like when you build number of metro stations, you need to do lot of efforts to build a metro station. We need to spend similar efforts of PPP or boot methods to build vertiports across the world. Then we need to detect and avoid collision. And we have to do communication requirements of UAV command and control, telemetry and data links beyond the current modus operandi of depending on the Wi-Fi frequency range. We need to do UAV testing, cyber security, and we need to keep our UAVs smart with enabling them with artificial intelligence and machine learning. We need to have large language models, definitely. But for UAV specific, we need to create the small language models, which is very effective for quick decision making, and artificial super intelligence and explainable AI to be used in making the UAV maneuvering autonomy more effective. Another recommendation is that innovation by multinational, multiracial, intergovernmental, collaborative efforts to robust MOPs and SOPs, methods of procedures and standard operating procedures for fail-safe, fail-proof, reliability handovers, redundancy of critical media, signaling and control infrastructures, associated cloud and data center edge resources for decision support to do right things and things right. This concludes my quick talk, and then I'm contributing along with Indian Institute of Science and IITs and professors and also industry like DRDO, ISRO, and Airport Authority of India, Indian Air Force, others to charter the law for Indian UAV architecture, which can have impact on others' research also in different countries. We are working with the standards available to us from Bureau of Indian Standard from all over the world, and we welcome your comments. Whatever we have published so far is kept in that link. If you double click that, you will find published reports of agriculture and other UAV related testing standard and also cybersecurity standard, generic requirements. And more work is going on UAV traffic management and beyond visual line of sight vertiports and detect and avoid areas and communication requirements of UAVs for next generation as the very topic today that we have taken up I really admire MDPI having chosen a most relevant topic for the industry. And thank you all for the time and opportunity given.
Thank you very much, Professor Kishore. Thank you very much for this very interesting presentation. We can, as according to MDPI presenter and Mrs. Maja Dragojevic, all the participants can put some question in the chat, in Q&A chat, and then we can try to answer to each question. Thank you very much for your presentation. Thank you very much for joining this webinar. And I would like to show a few slides about the situation about 6G networks and which is the link between these new standards and the upcoming standards and the UAV. So I would like only to comment a few slides from my presentation. I would like to only to comment a few slides about these 6G communication networks for drone features and applications, which is the link, which is the relationship between 6G networks, advanced wireless networks, and the drones in the future, in the upcoming years. First of all, according to the network 2030, we will have a 6G network very heterogeneous, able to provide a full convergence between terrestrial and non-terrestrial network by a native program. The network will be very intelligent because will be AI, ML, artificial intelligence, and machine learning based natively. And finally, this intelligence can also be put on the edge, at the edge of the network, very close to the user. This is a very simple idea, but the 6G open new frontiers from the technological point of view and several opportunities. As you can see, we have terrestrial networks, Internet of Things, apps, very low Earth orbit, LEO and MEO and GEO satellites, according to Professor Kishore said before. All these things, all these networks, all these different networks will be linked among them in an intelligent way, in a full convergent way, with also several applications able to interact among them. With no doubt, we have a technological triad because we have several applications in terms of blockchain, virtual reality, augmented reality, metaverse, and also AI and ML features. So the 6G communication networks will appear in the market in the upcoming years. In the 2030, in a context characterized by these three main groups of technologies. But the standardization process of the 6G already started because currently we are in the requirement definition phase. In the 2023, ITU already published the first official documents on 6G that corresponds to IMT 2030 as official name. So according to the timeline, we are currently in the phase about the requirement definition in order to arrive to the 2030 with the market launch of this technology. As I said before, the recommendation ATUR M2160 launched on November of 2023. We have a first draft of the framework and overall objectives of the future 6G. Which are the main motivation, societal considerations? We have inclusivity, ubiquitous connectivity, sustainability, innovation, standardization, interworking. These are the main drivers, the main motivations according to the Sustainable Development Goals at worldwide. In terms of user application trends, we have very power human-machine interfaces, high level of immersing experience, all the nodes, all the machines will be intelligent in terms of autonomous actions, responsiveness, precision, and so on. All these things are natively implemented by artificial intelligence. And also in the physical world, humans and machines are expected to interact with each other, with other. The first official documents already defined the two usage scenarios of the 6G networks, the future 6G networks, and we have 6 usage scenarios. The first 3 are belonging to the first IMT 2020 that corresponds to the 5G. Especially in red, we have immersive communication, massive communication, and hyper reliable and low latency communication. These 3 in green are belonging to the 5G, the previous 5G standards. But we have new 3 usage scenarios called integrated and senses communication, AI communication, and ubiquitous connectivity. In total, we have 6 usage scenarios, and we have a lot of system capabilities that are very, very powerful, rather if compared with the previous 5G standards. We have enhanced capabilities in terms of, for example, latency. The 6G will promise to reach sub 1 millisecond latencies. Will increase the security and resilience level, increase the reliability, and also will support a very important metrics in terms of mobility and connection density. And also 6G will add new capabilities such as coverage, because as we said before, 6G will provide ubiquitous connectivity, a very powerful and high level of accuracy in terms of positioning, sustainability, interoperability, and so on. Compared with 4G and 5G, the 6G will promise to reach up to 100 GHz in terms of carrier bandwidth, 1 terabit per second in terms of peak data rate, latency, as I said before, under 1 milliseconds, and so on. But I would like to underline that the 6G will be released with a full integration, native integration with non-terrestrial networks. As Professor Kishore said before, we have several equipments, several nodes called non-terrestrial networks that are represented by UAS, for example, hubs, high altitude platforms, low altitude platforms, and also satellite. We are currently experiencing several applications with supported by low Earth orbit LEO satellites, thanks to the low level of latencies. But I would like only to comment that the main idea of these technologies is that we can have 2 different non-terrestrial networks devices, systems, transparent and non-transparent. Transparent if the satellite of the UAV or the UAS is equipped with non-regenerative payload, so we don't have any kind of an onboard processing capabilities. If the system is non-transparent, it means that this system is equipped with onboard radio frequency filtering, frequency conversion, also processing capability. This is the 2 main different categories. In the slides, we only mentioned the most important characteristics about the UAVs. We can have several categories: nano, micro, mini, medium, and large UAV, different in terms of different specification as weight, battery, cameras, resolution, and applications enabled. But which is the main rule of the UAV and the UAV assisted connectivity enabled by the future 6G networks? According to the ITU main documents, we can have at the moment 3 main applications, 3 main UAV assisted connectivity modalities. The first one on the left on these slides, we can have aerial base station, ABS, where the UAVs are equipped with a flying base station able to support services belonging to emergency sector, or also to expand the rural connectivity, for example. In this sense, we can also enlarge the deployment of the future 6G, because since the 6G will use the terahertz communications, it means that we have a high level of frequencies and we will have a small cell in terms of coverage. It means that we will need to deploy base stations close among them. So in the first case, the UAV and also the UAV in the US is equipped with aerial base station. It acts as base stations. In the second case, the UAV is used for backhaul for acting as a relay of a backhaul connectivity. It means that the UAV can connect remote IoT devices with terrestrial networks, and also with it can communicate with the IoT gateways, terrestrial IoT gateways. So we can have two different modalities. On board, we can have a relay on the IoT gateways able to connect with IoT terrestrial devices. In the second subcase, we can have the IoT relay on board that able to connect with IoT gateway, terrestrial gateway. Finally, the third case, in the third case, we have the UAV able to connect the ground users, the satellite ground station or the final user on the ground users, with the LEO satellite constellations. It means that it is the intermediate that can act as an intermediation between the LEO satellite and the ground users. The 6G, one of the most important building blocks of the 6G is represented by intelligent reflecting surfaces that are surfaces able to modify the polarization on their surface, and then can convey in specific direction the radio frequency signal. It means that if we can have the intelligence reflecting surface on top of the building, for example, and we have a weak line of sight signal from the terrestrial radio base station and the direct to the UAV, we can have other controllable line of sight signal, alternative line of sight signal, able to be fully managed from the terrestrial base station versus the building, and also to be reflected from the building to the UAV. In this sense, the intelligent reflecting surface is able to be, of course, fully managed by the UAV in the next 6G networks. And what about the other building block? Belonging to the 6G. The other important building block of the 6G network is represented by integrated sensing communication, ISAC. The ISAC is the new generation of sensor nodes that are able to combine the sensing and communication features. And ISAC can allow communication signals also to serve all the sensing needs. It means that if we have this UAV at the center of the slide, the UAV is able to exchange both radar echo signal and radar transmitted signal from it to the sensor node or other sensor devices within the radar beam. And we have another beam starting from the UAV to the other node. In this sense, we have the end users able to convey the communication signal. So we have two different beams, radar beam and communication beam, from two different features, sensing and communication respectively. This is another important feature for the 6G the future 6G networks, and also will be implemented natively. Another important bit block in the 6G that is also already implemented thanks to the UAV is the blockchain. The blockchain is the overlay network created among different nodes belonging to the same blockchains, and thanks to the possibility to chain the different blocks, data blocks, we have a cascade of different data blocks chained among them. we can have the immutability of the ledger, that is the main register containing all the data exchanging among the nodes. We can use the token. It means that all the nodes can exchange tokens to communicate and to store their actions. And also we can also implement the conditional instructions called smart contract according to the if then else statements, software statements, for example. This blockchain approach can be also combined with the goal-oriented semantic networks, that is a prominent approach in the communication sector, where we can exchange only the semantic features on the physical channel and not all the entire input data. It means that if we have drones with different sensors, LiDAR, camera, GPS, and other sensors, the drone can exchange from to the networks on the users and the other nodes, the destination node, only the semantic features according to the specific goal. That's why this approach is called goal-oriented semantic network, because the semantic features are strictly related to the goal, the action, for example, face recognition, action recognition, speech recognition, and something like this. The onboard unit, it means the OBU, can transfer all the necessary data in terms of semantic features and not on all the input data to the destination node. What about the edge computing? Yes, also the edge cloud computing is another important building block for the 6G networks and UAV. Why? Because the UAV can according to the weight of the edge cloud computing server and so on, can host the aerial edge computing server. So we can the UAV can be equipped with this processing server on board that can be easily mounted on board, able to provide what? To provide backup, caching, processing, and this is very important, for example, when we are talking about emergency applications, when the UAV need to be connected with the remote server, the remote control room, and then need to exchange data, need to exchange, for example, in important photos, images, or video for this, the real scene, the real scenario that is that UAV is exploring. And this is very important because in this sense, the UAV can not only act as a relay of coverage, radio frequency coverage, signals, and so on, but also to provide additional computation and processing features of all the collected data. And finally, the swarm drones is the new paradigm able to enable very important features for the 6G networks linked to the UAV. The swarm drones are characterized by a huge number of multiple UAVs with robotic features. So if we, in the case of a single UAV, we have a small case mission with several constraints in terms of sensing and also energies and so on, operational reliability. In the case of swarm drones, we can have several opportunities in terms of what? In terms of enhanced collective intelligence, we have a distributed intelligence, and high level of coordination, increased operational flexibility. We have also high reconfigurability thanks to the, of course, autonomous actions and so on. And we can deploy the swarm drones according to different strategies, centralized control, and distributed scenarios, control scenarios. What about the role of AI and ML in this new generation of swarm drones that are being natively implemented in the 6G networks? First of all, we can have a distributed intelligence because the artificial intelligence can enable in a coordinated way all the effective operations in dynamic and complex environments, and also the related decision-making autonomous actions. The machine learning can allow UAVs to learn from their surrounding and also to adapt all the actions. We can also, thanks to AI ML, can also make a full high level of optimization of UAV operations. And also we can allow the enhanced collaborative sensing and also resource utilization, and also to support innovative applications, new applications performant in intelligent way. But what are the most important challenges for the swarm drones? Of course, we need to manage the stable and also low latency communications in a dynamic environment, the energy and power consumption constraints, also the security, because the cyber threats and in terms of data privacy and also the possible security attacks need to be careful managed. Also, the full integration with non-terrestrial networks. As we said before, we can have small drones able to be connected with to the LEO satellites, to the ground station, and also with IoT devices. So the seamless coordination and also the seamless handover, and also the seamless coordination of different actions or different applications is very, very important. And also the usage of unified protocols and also AI-driven management and all the features need to be put in a common way, in a common vision, of course. We of course also in this case with the swarm drones and the 6G we will have we can enable several important applications such as agriculture, precision agriculture in particular for the monitoring the landscape, the vegetation, and also the yield prediction, plants, and so on. Also to manage different data layers and then to reconstruct a very powerful data map of the surrounding environment. The other important class of categories of application is represented by the surveillance, able to put the observation and collection of data regarding environment, individuals, activities, infrastructures, and so on. And finally, in this sense, we can have camera surveillance, GPS tracking, radio surveillance, biometric surveillance as monitoring, and also scanning and iris recognition. And thanks to the features of the 6G networks in terms of very low latency and also high data throughput for the end users, and also the possibility to have several very huge coverage of the 6G signals. These applications regarding the agriculture, for example, surveillance and other ones can be very, 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 very enhanced respect to the 5G case. Finally, just one word about the Restart project. This is the research program here in Italy, the biggest research project in telecommunications according to the European Union Next Generation EU and the National Recovery and Resilience Plan. We have 8 spoke and 8 sub actions and UAV, and all these things about the intelligent networks, the AI enabled networks, intelligent communication networks, the role of the edge machine learning and virtual assistant, the possibility also to have a virtual assistant able to manage the end users and so on, are all the topics we are currently studying, we are currently developing within the networking sub-project that belongs to the Restart project, and also the full integration with non-terrestrial networks in terms of apps and UAV. Finally, the conclusion, there are several opportunities, of course, because 6G for UAV can provide increase very, as I said before, very low latency and high level of data rates, can enhance the connectivity, ubiquitous connectivity, and also the network density. But and we have also, on the other way, we have also several challenges to manage, for example, in terms of deployment, because the terahertz communication waves are strongly absorbed by atmospheric vapor and obstacle and so on. It means that these This obstacle can limit their propagation distance. We need to manage the challenges in terms of power consumptions and also the security and privacy because we can have several drones operation that can suffer from cybersecurity and privacy attacks. Thank you very much for your attention. I don't know if we have some question about this this topic about the 6G and UAV. Okay, so let me introduce, with a great pleasure to introduce the third speaker, that is Professor Parameshachari. Professor Parameshachari currently working as a professor at head of Department of Electronics and Communication Engineering at UTM-enabled Institute of Technology in Bengaluru, Karnataka in India. And he also working as an associate dean at NMIT. He also a visiting professor for University of Roma Tor Vergata. He is currently serving as vice chair in IEEE Bangalore section. He also listed in the world top 2% scientist by Stanford University, USA, for his research works. He is recognized as a research guide at VTU Belagavi, awarded 4 PhD and currently 5 research scholars were pursuing PhD degrees under his supervision. He has published over 150 articles in Scopus, SCI, and other indexed journal, and he also serving in several international conferences as associate editor for Expert Systems Wiley, International Journal of Computational Intelligence Systems Springer, and International Journal of Reconfigurable and Embedded System. He has also served as editorial board member, academic editor, and reviewer for several international journals, and he is the recipient of IEEE Bangalore Section Outstanding Volunteer Award, IEEE Bangalore Section Outstanding Branch Counselor Award, and IEEE Bangalore Section Chair's Recognition for IEEE Bangalore. He also served as lead guest editor for Springer, Elsevier, and IEEE journals. Welcome to Professor Parameshachari. His speech is called Revolutionizing Firefighting, the Future of Fire-Extinguishing Drones. Professor Parameshachari, welcome. The floor is yours.
Yeah, thank you for a nice introduction. And first of all, I take this opportunity to thank Alessandro Vizzarri for inviting me. And also, I would like to take this opportunity to thank the MDPI for giving us a platform to share our. So actually, what actually I would like to highlight here is mine is revolutionizing firefighting, the future of fire extinguishing drones. So I take this opportunity to thank our Determination Institute of Technology and also IEEE Aerospace and Electronic Systems Society. So they have sponsored one project for us. So to building the fire extinguisher unmanned aerial vehicle. We are working on that project. So the project is 3 phases. Just part of that project. I would like to brief out here during this webinar. So along with me, so 6 students are also working with me for this project actually. Just I would like to introduce what actually the firefighting. So generally we know that fire incidents causes significant damage to the life, property, to the environment, and we know that some traditional firefighting methods are while effective and is having some limitations, including the high risk to the firefighters, low responses time, and also restricted accessibility to high-rise buildings and the industrial zones. So with advancements in technology, the drones are equipped with the fire extinguishing capabilities as emerging as the modern firefighting. So as we know that the traditional firefighting methods, as I mentioned, the high risk to the firefighters entering to the burning buildings and hazards environment forces the life-threatening, dangerous, and delayed response time. The firefighters need to time arrival at the scene, which can lead to increased damages. And we have the one more limitation is the resource intensive. So resource intensive requires significant manpower, equipment, and the water supply. So the fire extinguisher drones are the unmanned aerial vehicles designed to detect, monitor, and extinguish the fires. And also, so these drones are how we are, during the emergencies. So drones plays a important role during the fire, during emergencies, especially in situations involving large fires and hard to reach areas or the dangerous conditions. They provide valuable information tools that help to improve the way the fires are handled, especially usage of the fireballs for fire extinguishing. The usage of fireballs for for use the fire suppression. Okay, so some drones are equipped with the fire extinguishing balls, which can be dropped over the fire. These balls burst on contact with the heat and release the fire suppressing chemicals. This helps to control fires in remote or the dangerous areas without putting the firefighters in harm's the way. So drones are powerful tool for modern firefighting, and they give real-time information and unique aerial view and safe fire suppression options. By using the drones, firefighters can work more safely, make better decisions, and control fires more efficiently. Ultimately, the saving life and property is the important things here. So we know how drones improve firefighting. The drones are changing the way the firefighters respond to the emergencies by flying the files, fire scene. Drone provide a wide and clear view of what's happening, and also they carry a special tool for help the firefighters more safely and they effectively. And with the drone, fire response become more efficient, more accurate, and better prepared to handle the emergencies. Already, as I mentioned, why firefighting drones are important. So, traditional firefighting methods are often slow and put human lives at risk, especially in high-risk buildings and the forest and the industrial drones. So, our goal is to improve the fire suppression efficiency while ensuring the safety for emergency responders. So, we have designed the octopeter aims to minimize the responses using the ML based, machine learning based detection and eco-friendly extinguishing techniques. So, how are we using the firefighting drones actually? In our project, we have developed an advanced firefighting drone to help to detect and control fires more efficiently. This drone is specifically designed to support the firefighters by working in dangerous or hard to reach areas using the smart technology and eco-friendly methods. So we have created custom-built octoputer that is strong, stable, and able to carry out the extra weight like sensors and the fire extinguishing balls. And also it uses the machine learning to detect the fire based on heat patterns and visual data. This helps the drone recognizes fire on its own without human help. And we have used, as I mentioned already, with the fireball drop mechanism. So the fireball drop mechanism is very important here. So drone is equipped with the fireball release system. This mechanism allows to drop fire extinguishing balls that specific target locations, making fire suppression and more accurate and effective. So these fireballs burst when they touch, they fire and release safe chemical to stop it. And also the drone is drone files autonomously, which means it can navigate on its own using the GPS and telemetry data. So this firefighting drone project, as I mentioned, is funded by IEEE Aerospace and Electronic Systems Society. And the goal is to transform modern firefighting by combining the drone technology, smart fire detection, and eco-friendly fire suppression. And it also shows how advanced robotics and AI can work together to save lives and protect the property. Our firefighting drone is powerful example of how technology can make emergency response safe, smarter, and more effective with automatic navigation, intelligent fire detection, and real-time support. This drone is designed to assist firefighters in the toughest situation and help reduce to damage during the fire emergencies. So these are some of the objectives actually we have come for this project actually. So we have built the advanced firefighting drone. So the goal is to design a specific drone for firefighting that includes features like thermal cameras and autonomous flying. And also we, as I mentioned, we have used the fireball drop mechanism. So this is drop mechanism is help us to control fires and also acts as the scout and helping the firefighting sees. They see the fire size and they choose the best places to enter, and also improve the autonomous operation. So we aim to make the drone smart enough to work on its own with less human control. It includes better navigation, decision making, and quick response to the fire situations, and also provide performance safety. So we build trust. We will test. We tested the drone, its fire drop mechanism in real situations. We'll make sure the safety rules and works, and consistently improving the design. We ensure the system both effective and safe for the firefighting use. So we have used some of the component for our project actually. So we know that drone typically comprising several subsystem, and the drone is used for firefighting applications involve structural and propulsion system, providing physical framework and movement capabilities and control navigation and ensure stability to guide the flight path, and communication data subsystem is facilitate the remote operation and data exchange with the ground stations for the other devices. Actually, this electronic speed controller is the key element component in drone. Main job is to control how fast the motor spin, which directly affects how the drone files and moves. Okay. So this electronic speed controller plays a vital role in drone flight. It regulates the motor speed and ensures the smooth operation, protects against the overheating, and also it helps to maintain flighty in advanced applications like firefighting, and reliable electronic speed control is essential for safe and the efficient drone performance. We have also used the BLDC, the brushless DC motor. So this brushless DC motor is also one of the important parts of the drone, especially when it comes to flying. It is the component that creates thrust, which is the force that lifts the drone off the ground and allows it move in the air. And this is the BLDC motor are powerful, energy efficient, and reliable, making them ideal for advanced drones used for firefighting. They ensure that drone can carry heavy equipment, fly steadily, and respond quickly to the control inputs. Their smooth and strong performance is what allows the modern drones to perform complex and demanding tasks safely and effectively. So another simple component we used is power distribution board. So power distribution board is also play important part of, sorry, it is also very important part of the drone electrical system. It acts like power sharing station, sending electricity from the battery to all other parts of the drone that needed it. And also this power distribution is for firefighting drones. A well-defined power distribution board ensures that all onboard systems from motors to camera work reliably in every counts. We have also used the flight controller. So Pickshock fire controller we have used here. The Pickshock fire control is the powerful and flexible control system, makes smart, stable, and autonomous drone operations possible. In firefighting drones, it plays a key role in ensuring safe flight and accurate navigation and seamless integration with the AI systems, ultimately improving the response efficiently reducing risk to the human firefighters. We have also used the telemetry module. So actually the telemetry module is a very important part of the firefighting drone. It acts like wireless link between the drone flying in the air and the ground control station on the ground, where the operators monitor and control the drone. So telemetry model also allows the drone and the ground team to talk each other live. Okay, this means the drone can send important updates while it's flying, and operator can send new instructions if needed. The telemetry systems work over long distances, which is very helpful during the large operations in the forests or the remote areas. Even if the drone is far away, the ground team can still control it and receive the updates. So the telemetry module makes it possible to monitor and control the drone from far away while receiving real-time informations. So next, one more what we have used is the FVP. Okay, FPV camera, the first person view. The first person view is a special type of camera mounted on the drone that gives operator live video feed from the drone's point of view, just like seeing the through the drone's eyes. It is very important for controlling the drone and making quick decisions, especially during the firefighting missions. So this is actually by improving the visibility, we are supporting manual flight and helping real-time decisions. This FPV camera greatly increases safety, accuracy, and efficiency in the firefighting missions. One more component what we have used is MLX 90640 thermal PI camera. So this is a special camera that can see the heat instead of light. It's used for firefighting drones to detect high temperatures, locate fire hotspots, and help identify the people or the objects, even though smoke and the darkness. Actually, when paired with the uh, Raspberry Pi, and it becomes smart tool that improves both safety and the response effectiveness. So we have also used the servo release hook. Servo release hook is the mechanical part actually that attached and fire, but it plays a very important role. Make sure the drone drops fireballs at the right place and the time. Is This servo release the strong mechanisms helps the firefighting drones carry and release the fireball safely and accurately. It also work autonomously using the servo motors built to withstand with the weight and heat to firefighting the operations. So this fire extinguishing ball, already as I mentioned, is a special firefighting device is designed to automatically put out fires. It is a round and lightweight ball that is easy to use and can be dropped by drones to help control fires from the air. This tool is especially helpful in situations where sending firefighters is a dangerous or the impossible place. And this is the system architecture. Actually, this analysis is looks like how a drone built with a special focus on how its power is shared across different parts, and designing the system carefully. Very important for any drone. The system architecture like a blueprint showing how the electrical parts like the battery, fire controller, and motors work together smoothly. And clear design helps the power is sent correctly and reliably to each part of the drone. It also helps in choosing the right component and improves the drone's flight performance and features. And so we have used some of the blocks actually, so the sensors and cameras. So drone uses the different sensors and cameras to collect the important information and FPV cameras to capture live video during its flight. And we have used the Firefighting fixed shock. This is the main controller of the drone, and it controls the controls and connects all the motors and servos, making sure everything works together smoothly. And we have also used the Raspberry Pi, so is used to handle the ball drop system, and also it runs machine learning program, uses PI cameras to drop the ball accurately. And also we have used the motors and servos. So the drone has 8 DC motors that control the propellers to help it move in different directions, and 4 servo motors that control the ball drop with the precisions. We have also used host PC. Actually, the host PC or this computer sends control signals to the drone, shows the FPV video, and also uses the software called Mission Planner to send important data. So as I'm already told, power distribution board. So PDB we have used here. So it connects the Picshock battery and the speed controllers, and also it helps in sharing uh, power properly to all parts of the drone. So we have subsystem actually. So then we have payload mechanism. Actually, the payload mechanism is the specially designed to carry and release fire extinguisher balls using the servo hook system. This system is 4 individual hooks. Each hook can hold one fireball. So the hooks are operated using the 4 separate servo motors, one for each hook. These servo motors are programmed to release the fireballs one at a time, depending on where the drone is during its flight. The drone can drop fireballs at 4 different locations instead of dropping all of them at once. So the mechanism is lightweight and securely hold the fireball during the flight and ensure they do not fall off accidentally. Okay, so this controlled and flexible design makes the firefighting more effective, especially in remote areas. The material selection is also very important actually. So after completing all the thorough literature review, running several simulations, we start assembling the components of the firefighting drone. So the frame of the octoputter is built, and we have chosen the carbon fiber for the material of the frame. So why we have chosen the carbon fiber actually? Carbon fiber is known for being very strong while still being the lightweight, and important for drones, as a strong frame is needed to carry heavy equipment like motors and the cameras. So while light frame helps the drone fly longer and more efficiently, and also the durability is also good, since our drone will be used in high temperature and tough conditions. So the carbon fiber is highly durable, can resist heat, making it perfect for flying close to zones. And the better performance, the carbon fiber has good aerodynamic properties, which means it can cut through the air smoothly and helps the drone fly better, safe, um, stable in the air, and move quickly when needed. So the carbon fiber helps to build the drone that is strong, light, and heat resistant and easy to control, making it ideal material for our firefighting octoputter. We have done the assembly actually. In the assembly, this is the assembly actually. Assembly of the drone is we are bringing together all the main parts such as frame, motors, propellers, flight control, and sensors. Each part was chosen after careful testing. Make sure it works well and reliable. It gives best performance. So the frame we have designed to be strong and lightweight. It can handle different types of flight movements while staying stable in the air. And we have, so as I mentioned, propulsion system has 8 powerful brushless motors. Each motor is connected to a specially chosen propeller that helps the drone lift off grounded and move smoothly in all directions. These propellers are connected to the flight controller. So that is PICSA controller using the electronic speed controllers and ellipse controller speed of the motors. So four servo release hooks are mounted on every second rod of the drone's frame. These hooks are used to hold and release the fire extinguisher balls and are securely supported to the handle and the handle. So this flight controller dedicated slot to the top plate of the drone frame. It's connected to the Raspberry Pi, which helps with additional tasks like running AI models and GPS model, which helps the drone knows its exact position. So finally, all connected parts, including the propellers, motors, sensors, and servos are carefully calibrated and tested using the mission planner software. The software helps set up and fine tune the drone so everything works together smoothly during the flight. And we well integrated assembly ensures that drone perform reliably and effectively during the firefighting operations. So actually we have tested also. So I will try to play the video. I don't know whether it will play. We'll see. So we have We have tested actually the main goal of the flight test program was carefully check how well our octoputter performs three key areas: maintaining the altitude and staying stable during the flight, and also the at a fixed position. So actually, after designing this octoputter, so we have moved on to the swarm drones actually. The As you know, swarm drones are a group of multiple drones that work together as a team to detect, monitor, and suppress the fires. By combining the power of many drones, this system can cover large areas quickly and respond to the wildfires more more efficiently and safely. So the swarm drones minimizes the human risks. Actually, it is more powerful and intelligent and safe solution for modern firefighting. So, with their ability to monitor, map, and respond the fires, they help firefighters make better decisions and reduce risk and control fires more effectively. Uh, so actually, drones are uh, transforming the firefighting by providing real-time surveillance, generating heat maps, and predicting the fire speed, enabling faster and more strategic responses. And also, they minimize firefighter risk by assessing the hazards areas before human interventions with scalability and efficiency. The multiple drones can coordinate to cover large fire zones, adapting dynamically to changing the conditions behind fire suppression. They assist in environmental monitoring, tracking air quality, and aiding reforestation efforts. And AI-powered swarm drones autonomously detect and analyze the fire hotspots. Okay, so while leader-follower coordination ensures efficient task distribution, their rapid deployment in remote or high-risk areas enhances the response time. And the fire suppression drones can directly release the water or retardants. As the technology advances, the AI automation and real-time data analytics will further solidify drones as a critical tool in modern firefighting. So in future, the firefighting drones looks as promising as the advancements of integration of 5G connectivity, the use of 5G networks that allows drones to send and receive data much faster than before, with almost no delay. And the use of swarm drones are also group the work together automatically like a team without needing to control the one by one. These drones can cover large fire zones quickly by dividing the area among themselves. So, in big fires like forest fires or industrial accidents, swarm drones reduce the response time and increase efficiency, making firefighting drones efforts more successful. So, AI-driven predictive analysis using the AI and machine learning drones will be able to study weather patterns, temperature, wind, and terrain to predict where the fire might happen. So the drone can identify fire risks before they start, allowing emergency team to act early. If a fire has already started, so AI can predict how fast, in which direction it will spread, helping the firefighters plan better. This technology makes possible to prevent fires from getting out of control, saving both the lives and the property. So in future, the firefighting teams will use a group of drones called swarm that work together as a team to detect and monitor to help control fires actually. So finally, the key takeaways actually, the drones are transforming the firefighting by increasing safety, reducing response time, and enhancing the fire suppressions efficiently. And the fire active porter is an autonomous drone equipped with ML-based detection, real-time monitoring, GPS tracking, and the co-friendly. So drone technology, the rapid advancement, AI communication, drone design, and the swarm drone, as I mentioned, it is multiple drones to coordinate firefighting, so they know not to communicate one by one. So with this, I would like to conclude my talk. So thank you. And these are some of the bibliography references I gone through my presentation. So once again, I take this opportunity to thank the MDPI, and also I would like to thank the Aerospace IEEE, Aerospace and Electronic Systems Society for sponsoring the project to NITM Institute of Technology. And I would like to acknowledge the efforts of my students working for this project. So still we are working the swarm drones for improving our project. So thank you for your patience listening.
Thank you very much, Professor Parameshachari. My congratulations for your project, for your team. We have a couple of questions for your project very, very quickly. I would like to a couple of comments from your side. The first question is about how large area can be extinguished by a single fireball. Is about how can be large the area extinguished by a single fireball. This is the first question. And
Okay.
the second question is about the possibility to provide sensor measurement data logged by Pixelwalk. In this context, especially interesting data are pressure, temperature, and local global positions estimated by EKF filter. So we have these two questions, please.
Actually, the fireball is measures 152 meter in diameter and it weight around 1.3 kg.
Okay. And finally, what about the possibility to provide sensor measurement data logged by Pixelwalk?
So the Pixwalk actually the fire controller it is we have used actually the Harm Cortex M7 is around 480 megahertz and
Okay.
uh, so yeah this 480 megahertz and 2 MB flash memory and that is actually the with an input voltage of the 6 volt.
Okay, okay. Thank you very much again, Professor Parameshachari. Thank you very much.
Yes.
So we can let me introduce the other speaker of this webinar. That is Dr. Jewel Sengupta. That is a currently PhD student in informatics engineering at Kaunas University of Technology. Jewel's professional voyage started as Kaunas University of Technology, where he served as a project junior researcher from in 2023, and he has published articles in SCI Scopus indexed journals and also in several international conferences. Dr. Sengupta is a dynamic and accomplished professional with a passion for technology and AI, especially in the fields of bioinformatics and geoinformatics. The title of his speech is Deep Learning for Super Resolution Enhancement of Drone and Satellite. So, Doctor, the floor is yours.
Okay, good morning, everyone. Thank you, Dr. Alessandro Vizzarri and other organizers, Maja, for giving me this wonderful opportunity to present a talk on this deep learning for super resolution enhancement of drone and satellite image. I have been working as a PhD scholar and now a project specialist at KTU Kaunas University of Technology in Lithuania at the Department of Applied Mathematics. That's the brief introduction for myself, and let's dive into the topic now. Can you confirm, is it moving to my next slide?
Yes, it moved.
Okay, thank you for confirming. Okay, so super resolution technology enables the enhancement of image resolution beyond the physical limits of imaging hardware. It employs advanced computational techniques to generate high-resolution images from lower resolution inputs. Super resolution can be categorized into single image super resolution and multi-frame super resolution, while SISR relies on deep learning and interpolation methods. MSSR synthesizes information from multiple images to reconstruct details more effectively. The impact of super resolution spans various domains, including like medical imaging, where it improves the diagnosis, clarity, segmentation, and for satellite imagery, aids in environmental monitoring and security surveillance. Enhancing critical visual data with the deep learning advancement model like convolutional neural networks, GAN network, and pushing the boundaries of what super resolution can achieve, making this high quality image reconstruction and more accessible and effective. Okay, so traditional imaging system often struggles with limited resolution, which affects accurate training process, analysis, and environmental monitoring. So SR mitigates these limitations by reconstructing finer details from the lower resolution images. A key application is environmental monitoring, where ESR enhances the detection of deforestation patterns or glaciers movements, natural disasters assessment with better resolution. Climate scientists and environmentalists can track changes with greater confidence with this. Moreover, this super resolution is highly valuable for security and surveillance, as it refines satellite-based target identification and border monitoring. Urban planners and agricultural specialists also benefit, as high-resolution imagery supports better decision making in infrastructure development and resource management. Drone and satellite imaging face significant hurdles despite its vast potentials. Weather conditions such as cloud cover, storms, and atmospheric disturbances can severely degrade this image quality, making data collection unreliable. So high resolution imaging produces massive amounts of data that require robust processing infrastructure and efficient storage solution to manage effectively. So, last but not least, the legal and ethical concerns are also very crucial. Governments enforce strict regulation to ensure responsible data collection, balancing security and privacy. And finally, power limitation presents a major challenge. Drones rely on battery life, while satellite must optimize power from solar panels to ensure continuous operation. So as technology advances, overcoming these challenges are key to unlocking the full potential of drone and satellite imaging in the fields like agriculture, surveillance, and disaster response. Super resolution can be broadly classified, as I said before, into two categories: single image super resolution and multi-image super resolution, each following unique advantages. Single resolution has a single input image, as the name suggests, using the deep learning and or interpolation techniques, making it useful in applications where only one image is available, such as security footage enhancements and smartphone camera processing. However, its reconstruction accuracy is often limited by the absence of additional contextual information. Whereas MISR, multi-image super resolution, leverages the multiple low resolution images to reconstruct a high resolution output. This approach is particularly effective in satellite and medical imaging diagnosis, where capturing multiple frames from slightly different perspective allows for better detail restoration. And due to its reliance on multiple inputs, MISA generally outperforms single input super resolution in reconstructing finer textures or mitigating noise. Traditional methods for super resolution focus on enhancing the resolution of low resolution images using various mathematical and computational techniques. These are two major methods or approaches are being followed. One is interpolation based approach, which where bilinear interpolation estimates pixel values based on a linear combination of the 4 nearest pixel values. Is very simple and like fast approach, although it has the limitation that results in blurry images because it doesn't capture high frequency details. It also introduces aliasing artifacts in some cases. Then bicubic interpolation also is there, which uses 4 into 4 neighborhood of pixels to compute the new pixel values based on cubic polynomials. It provides better quality than the bilinear interpolation, but it has also limitation, like it reduces blurring compared to bilinear interpolation. It still struggles with fine details and edges. It may also introduce rigging artifacts around edges. Second one is model-based approach, where one method is sparse coding, which represents an image as a sparse linear combination of dictionary elements. The dictionary is learned from a set of training images, and the goal is resolution 1. Limitation is it requires a good dictionary, or called as the feature vectors, which can be computationally expensive to learn. The quality of the output heavily depends on the training data or the dictionary used, and it may not handle the complex textures well. This approach involves learning a set of basis functions or atoms from a set of training images, which are used to present the image as a sparse combination, as I said. So the major limitations of these traditional methods are like interpolation and sparse coding are not capable of recovering fine-grained details that were lost during downsampling. And they tend to smooth the image rather than sharpen it, and leading it to a loss of textures and finer features. And model-based approaches like dictionary learning can be computationally expensive, requiring the time-consuming training and optimization processes. Many traditional methods assume linear relationships between low and high resolution images, which may not hold true in a more complex scenario or real world images. This can limit their ability to reconstruct high resolution details accurately. Even with more sophisticated methods, traditional techniques often introduce artifacts like ringing, blocking, and aliasing, which can degrade the image quality. And last, traditional methods often fail to generalize well across various image types or adapt to the diverse nature of real-world images, leading to poor performance in unseen datasets. Overall, traditional SR techniques, while functioning, often fail to produce high-quality results when compared to more modern methods, such as deep learning based model I'm talking about here. The example-based approach is widely used in the computer vision community to incorporate prior information for image enhancement. This strategy either explores the internal connections and similarities within the same image, or learns a mapping function between low and high resolution image pairs. Depending on the training sample, example-based methods can be adapted as a general purpose super resolution techniques. One of the most well-known example-based methods is the sparse coding-based approach. This method follows a structured processes to achieve super resolution. Most external example-based super resolution method follow a similar workflow, emphasizing the optimization of low and high resolution dictionaries, or refining mapping functions to improve reconstruction accuracy. The performance of this method when trained on different datasets have been illustrated in this figure. The results indicate that given the same number of backpropagation iteration, training on ImageNet yield better performance than compared to the 91 image dataset. This suggests that increasing this dataset size can further enhance the effectiveness of this approach. However, ImageNet was not chosen as the primary training set because our model is relatively compact and shallow, limiting its ability to fully leverage the extensive information within the ImageNet dataset. Meanwhile, the 91 image dataset already captures sufficient variability in natural images, making it a suitable choice for training. However, limiting by its building, the final performance of DenseNet is relatively low, as you can see in the right graph, in comparison with the Dense 13 and 5 dense layer methods. SRCSN is a method presented in 2014 by Chao Dong researcher. As its name suggests, it's a technique that leverages convolutional neural networks for super resolution. Before its introduction, CNN had not been widely applied to super resolution tasks, making this approach highly innovative. SRCNN takes a low resolution image as input, transform into higher resolution version by learning a mapping function through training data. So one of the key advantage of this SRCNN is its simplicity. The architecture consists of only 3 layers, indicating the output layer. The first layer is responsible for extracting image patches. The second layer performs one linear mapping, and the third layer reconstructs the high resolution image. This straightforward yet effective design contribute to the success in this field of image super resolution. This SRCNN image has clearer outline of the building than the input images. The PSNR value for this image constructed by SRCNN was around 25.78. So here are the key advantages of using SRCSN for such applications. First of all, SRCNN effectively increases the spatial resolutions of low resolution images, which is crucial for satellite and drone applications where high details is needed. Unlike traditional interpolation-based methods, SRCNN learns directly from data, optimizing features, extraction, and reconstruction. Compared to bicubic interpolation, SRCNN recovers finer textures and sharper edges, beneficial for remote sensing tasks, which were like struggled by the traditional methods before. Once trained, SRCNN runs relatively fast on GPU-enabled devices, making it practical for real-time applications also, if it is needed. So works well for different spectral bands like visible or infrared from satellites and drone sensors. But then also there are some drawbacks for this SRCNN. Like it has a relatively shallow architecture, making it less effective than newer deep learning models, which can be explored like ESR, GAN, or EDSR, and PRCNN. We are working on those models, so maybe it will improve the quality and computation time much better. And it can introduce unwanted artifacts or blurring, especially in highly textured satellite image. High computational cost can be also a problem because it's fast, but training SRCNN requires significantly computational resources and high resolution datasets to train. Struggles with high level of noise, atmospheric distortion, or sensor specific degradation sometimes. So in conclusion, I can summarize that SRCNN has proven to be a valuable deep learning method for enhancing the resolution of drone and satellite images. Its ability to recover fine details and improve image clarity makes it particularly useful for remote sensing application. However, its limitations such as susceptibility to artifacts, high computational resource during training, we have tried with minimal noise, so introducing some noisy data, and it worked well with better precision. But if it is severe, we are not sure how good it will work. And uh, for practical applications, SRCNN remains a viable choice when a balance between speed and performance is required, especially for real-time or resource-limited environments. However, for more demanding tasks requiring high-quality image reconstructions, as we know, so advanced models like the ones I said before, we are working, and it may be more suitable. Ultimately, the choice of this super resolution technique should align with the specific requirements. What is the requirement there for that application? Considering factors like resolution, what resolutions is needed, computational resource, and noise robustness. That's from my side. Thank you for your attention.
Thank you very much, Dr. Sengupta. Any question about this other important contribution? Okay, thank you. That's it. Thank you very much, Dr. Sengupta. Let me introduce the last speaker. Professor Miguel García Torres is an associate professor in the Escuela Politécnica Superior of the Universidad Pablo de Olavide. He received a degree in physics and a PhD degree in the computer science from the Universidad de Laguna, Tenerife, Spain. And after obtaining the doctorate, he held a postdoc position in the Laboratory for Space Astrophysics and Theoretical Physics at the National Institute of Aerospace Technology. Then he joined in the Gaia mission from the European Space Agency and started to participate in the Gaia Data Processing and Analysis Consortium as a member of Astrophysical Parameters Coordination Unit U8. He has been involved in the object clustering analysis development unit since then. He has published over 100 articles in SCI, Scopus, and other indexed journals, and he also in several international conferences. He's serving as editorial board member and reviewer for several international journals, indexes in SCI and Scopus, and his research areas of interest include machine learning, metaheuristics, big data, time series forecasting, bioinformatics, and astrostatistics. The title of the speech of Professor Miguel García Torres is Trends and Challenges of Applying Machine Learning in Real Life. Professor, the floor is yours. Thank you very much. You are welcome.
Thank you very much for the invitation. Can you see my shared screen?
Yes, we can see.
Okay, thank you very much. Well, in this talk, I will explore some key concepts about machine learning and artificial intelligence, like explainable artificial intelligence and digital twins. And something that it's important is that, well, nowadays the explosion of data has fueled the rise of machine learning and artificial intelligence. This data revolution is driven by the increasing ability of digital information, Internet of Things devices, and cloud computing advancements. The heart of data revolution is machine learning. It stands in the shift to how to approach problem solving. We now have the ability to train the algorithms of vast amount of data, allowing them to form patterns and make their own decisions. It has profound implication on our daily lives. For example, machine learning algorithms can now recognize speech, translate languages, and detect fraud, and even drive cars. They are becoming increasingly adept at tasks that were once thought to be the exclusive domain of human intelligence. Something important to know is what is machine learning. When we talk about machine learning, it refers to a system's ability to improve its performance on a task based on experience and evaluated by a perform metric. A classic example is learning to play checkers. The task playing, the performance measure is the percentage of games won, and the experience comes from data on previously played games. A significant milestone in the history of artificial intelligence in general and machine learning in particular was IBM's Deep Blue. It defeated the world chess champion Garry Kasparov in 1997. Although Deep Blue's victory was achieved through brute force computation rather than modern machine learning techniques, it demonstrated the potential of artificial intelligence in complex decision-making tasks. Machine learning has been successfully applied in various fields, including medicine, industry, finance, and security. From medical diagnosis to fraud detection, its impact continues to expand. Facial recognition, for example, is one of the more obvious applications of machine learning. People previously received name suggestion for their mobile photos and Facebook tagging, but now someone is immediately tagged and verified by comparing and analyzing patterns through facial contours. Product recommendation is another field. Do you wonder how Amazon or other retailers frequently know what you might like to purchase? Thanks to machine learning, targeted marketing with retail uses machine learning to group customers based on buying habits or demographic similarities, and by extrapolating what one person may want from someone else's purchases. Sometimes you may end up with an off-base recommendation, but don't worry because not buying it is another data point to learn from. Another example is spam filtering, in which successful spam filtering adapts and finds patterns in email content that is undesirable. This includes data from email domains, a sender's physical location message, text, and structure, and of course, IP address. Now we can see that in industry, the impact of machine learning is growing because we can see that companies worldwide is investing in the development of these technologies. And for example, in retail, the use of artificial intelligence is expected to grow from $8.4 billion in 2022 to $45.7 billion by 2032. This growth has made artificial intelligence, machine learning, and related knowledge promising careers. However, we must face some challenges. Despite its potential, the adoption of machine learning in the industry faces obstacles such as the lack of high-quality data, the need for computational infrastructure, and, of course, resistance to change within organization. Other important challenges that remain are data privacy, security concerns, and the need for robust data governance frameworks. Furthermore, organizations must adopt responsible artificial intelligence strategies and enforce regulation to protect consumer information, ensuring ethical and responsible data usage is crucial for sustainable artificial intelligence development. For example, here we can see some of the trends like explainable artificial intelligence, no-code machine learning, digital twins, generative artificial intelligence, as we can see, for example, with ChatGPT or Gemini, deep learning, as in the previous talk, etc. So now we will focus in explainable artificial intelligence, and then we will continue with digital twins. Here, one of the biggest challenges in machine learning is the opacity of the models. Explainable artificial intelligence seeks to make models more transparent and understandable for humans, which is essential in critical sectors such as healthcare and banking, for example. For example, Amazon Alexa's voice assistant has been in the spotlight after viral videos showed that the device gave supportive answer about voting for Kamala Harris, while refusing to respond to similar questions about Donald Trump. You can also find a new Harvard research that the answer of a search in Google, for example, or any other search engine, depends on the language. So it has a language bias. It also happens in search engines as YouTube, Wikipedia, ChatGPT, etc. Therefore, people obtain different search responses depending on the topic and the language of the query. If you search an image about audience, you will get the image of a white boy. This bias is due to the data with which the model has been trained. There is a fine line between correcting the algorithm to avoid biases or wanting to add a specific bias. That's why it's important to understand the reason behind the decisions made by the algorithms. Here, we can see that devising artificial intelligence model has raised concern about different industries. Understanding how models reach their conclusion is crucial to ensuring fairness and reliability in their decision. Here in the image, we can see in the top images that it is capable of identifying shapes. And we focus on some pixels about to know why it has identified as a shapes and not as a code. In down, for example, in the bottom images, you can see that the difference between bird and person, in which we can see in that the pixel in which the algorithm focus in order to identify as a bird and to identify as a person. Well, here we can see some challenges which face explainable artificial intelligence. For example, complexity of artificial intelligence model. The demand for more effective decision-making can lead to the adoption of increasingly complex artificial intelligence models that are difficult to explain. Shy systems must be continuously improved to keep pace with these changes and maintain the ability to provide meaningful explanation for artificial intelligence decisions. Another challenge, for example, is standardization in Shy, which refer to the creation of uniform guideline, protocol, or best practices that define how Shy systems should function. These standards ensure consistency and reliability and compliance across industry and jurisdictions. Therefore, the lack of standardization allows for manipulation of results when comparing Shy methods. Another example is data privacy and security. While analyzing public and private data can provide valuable insights for decision-making, sensitive data may need to be used to explain certain decisions. However, the use of such data must be carefully managed to prevent it from being exposed to vulnerability and hackers. Finally, is the user understanding, which is another example in which even though Shay aims to make an artificial intelligence model understandable, some users may not have the necessary background knowledge to fully understand the explanation provided by Shay. Therefore, this system must be designed to provide explanations that are tailored to the needs and knowledge level of different user groups. Another trend are digital twins. Digital twins are basically virtual representation of physical objects or systems. They are used for simulations, fault prediction, and process optimization. For example, a famous example is the use in the Apollo 13 mission. 50 years ago, around 300,000 kilometers away from Earth, 3 astronauts were shaken by a jolt in their small spacecraft. Then, the cabin was illuminated with warning lights, and a cacophony of alarms began to ring. Something was wrong. However, they were unable to see the full extent of the terrible damage. What they didn't know is that an explosion in the oxygen tanks had critically damaged the main engine and left the valuable oxygen supplies leaking into space. How did they diagnose and solve the problem? To find innovative ways of conserving power, oxygen, and water, they had to simulate different scenarios with complex technology. Although these simulators are not digital twins, we can consider this milestone as the first example of digital twins. We can define a digital twin as a virtual dynamic model of a physical object, process, or system, updated with real-time data to simulate and monitor its behavior, enabling better decision-making and optimization. Digital twins can be used in various industries, such as manufacturing, healthcare, and urban planning to improve efficiency and predict potential failures before they occur. Here, for example, we can see that the Singapore faced a challenge because they wanted to develop a smart city environment to plan everything, from emergency evacuation to comfortable urban living. To do so, it developed digital twin of the city-state of Singapore. It enabled users from different sectors to develop sophisticated tools and applications for test bedding, concepts, and services. It also helps in planning and decision-making, and research on technologies that could solve complex and emerging challenges in the country. For example, it allows to improve the management of Singapore's limited land resources and identify areas at higher risk of flooding. So, machine learning is transforming the industry. The digitalization of industry has allowed to evolve to new opportunities and, of course, also face new challenges. The market for machine learning and artificial intelligence is rapidly growing, and the widespread adoption of machine learning and artificial intelligence in industry demand professionals with a blend of technical skills, including programming languages, data science, techniques, and domain knowledge, alongside soft skills like critical thinking and problem solving. So this can be applied to any technology, like, for example, drones and any Internet of Things devices that are being developed. Thank you very much.
Thank you, Professor Torres. Thank you very much for your contribution. Any question for this last contribution? Okay. So, in the conclusion of this important webinar, I would like to thank all the speakers, Professor Kishore, Professor Parameshachari, Dr. Sengupta, and Professor Torres for their very important contributions for this webinar. Professor Kishore underlining the importance of the UAV and the non-terrestrial networks and also the challenges in terms of integration of satellite, innovation, standardization, and other important features, the collaboration on this subject. Professor Parameshachari presented a very important a very interesting project about the firefighting drones in order to respond to fire incidents quickly and effectively, and also the importance of the swarm of drones in the future of these technologies. Dr. Sengupta talked about the high-resolution videos with AI/ML and how we can use deep learning techniques for drone and satellite images. And finally, Professor Torres underlined the importance of AI/ML, digital twins, and these important technologies for the ecosystem of drones in the next years. I would like to thank all MDPI staff, in particular Maja, for supporting us and all during the organization phase. And I hope that all the technical subjects, the technical points we analyzed this during this webinar, you consider it as important as to deeply analyze it in the next years. And we hope to find you in other webinars. And thank you very much for your contribution, your participation. Thank you.
Thank you very much, Alessandro. We have just received one question in the Q&A box. If you wanted to check out,
I'm sorry. I didn't see it. I'm
No,
sorry.
it's just received. No worries.
Yes, this
It's
is a
for the
question
first
for
speaker.
Professor Kishore.
Yes.
Um, Professor Kishore, can you hear me? Are you able to, I don't know if Professor Kishore is available because
Yes.
I think he is not available. Professor
Okay.
Kishore is not available. I think he left.
Oh,
Yeah, he
okay.
mentioned.
Anyway,
Yes, unfortunately, yeah.
Anyway, we can we can send this question to the professor, and then we can publish the answer to this question, Maya, if you.
Yes, we can do
Okay.
it.
Okay.
Okay. Thank you very much. I would like to thank you for chairing this webinar, and also I would like to thank our speakers for their time and interesting contributions to this webinar. And thank you for our attendees. I hope that you found this webinar interesting. As a reminder, yes, we will upload the recording of this webinar online as soon as possible. And that is it from our side. I wish everyone a nice day, morning, evening, wherever you are in the world. So have a good day.